Hello, I'm Lima Felix. I did my post-graduation in physics from Petromada National College. My topic for the poster presentation is Samarium top Strontium magnesium borate phosphor for yellowish orange light emission. Persistent luminescence is an intriguing phenomenon that has fascinated humans for quite a long time. The potential applications of borate-based phosphors in luminescent devices and the publications and research related to it have motivated us to synthesis and study a new borate-based phosphor, Samarium strontium magnesium borate. In this study, we are interested in the analysis of spectroscopic properties and photoluminescence of this phosphor. With the aid of scanning electron microscopy and energy dispersive X-ray spectroscopy, the morphology and elemental composition of the phosphor were determined. X-ray diffraction is utilized for the study of phase changes and crystallite phases under phosphor. The energy bandgap and bonding nature of the phosphor were examined using the absorption spectrum. The presence of ionic bonding nature in phosphor was obtained from the nucleostic ratios by analyzing the absorption peaks. Using absorption peaks, U depth of the phosphor were detected. Photoluminescence of the sample was studied and colorimetry analysis was done to identify the emission of color. This phosphor was synthesized using a conventional solid-state reaction technique. Using an agate mortar set, stoichiometrically weighed starting materials were thoroughly mixed. The mixture was melted at 800 degrees Celsius in an aluminum crucible for 2 hours in air using a muffled furnace and then cooled to room temperature. The resulting product was again ground and used for the study. The same image of the phosphor is given in figure 1 and figure 2 represents the EDX pattern of the sample. Figure 3 depicts the XRD pattern produced from the sample. A total of 30 peaks were observed in this pattern. Figure 4 represents absorption spectrum of the phosphor. The spectrum highlights 17 peaks in the UV visible wavelength region. Of these, the peak at 400 nanometer associated with 6H5/2 to 6P3/2 transition is sharper than the others in the spectrum. Figure 5 illustrates the plots of photon energy versus alpha h nu raised to 2 and alpha h nu raised to 1/2, and the corresponding x-intercept is obtained by drawing a dotted straight line in each case. Thus, the optical energy bandgap of this phosphor is taken from the intercept of tangent to the x-axis and is found to be 4.942 electron volt for a direct allowed transition and 4.79 electron volt for an indirect allowed transition. Table 1 shows the values of mu Z, mu A, and beta for each transition as well as the area of each peak. Out of the total 17 peaks, 16 of them have beta greater than 1, which results in the averaging of beta to estimate beta dash. I mean, beta dash is the average value of beta, and delta. Delta means the bonding parameter. Thus, the bonding parameter is obtained as minus 0.314, indicating ionic nature of SN3 plus ligand bonds in the sample. Now, table 2 shows the values of U lambda, F experimental, F calculated, and delta F. F experimental means the experimental oscillator strength, and F calculated means the calculated oscillator strength. So, delta F means delta F equals F experimental minus F calculated. RNS deviation sigma between F experimental and F calculated was obtained from the equation sigma equals sigma of summation of delta F the whole squared divided by Ni the whole raised to 1/2, where Ni represents the total number of transitions. The value of delta F was obtained to be 0.00005 into 10 raised to minus 6. And sigma is obtained as 0.002 into 10 raised to minus 6. The photoluminescent spectrum shown in figure 6. It shows 4 peaks at 557 nanometer, that is 4G 5/2 to 2 into 6, 2 6H 5/2, and 599 nanometer, 639 nanometer, and 699 nanometer. These emissions are helpful for color displays, medical diagnostics, and high-density optical storage devices. The CIE 1931 X5 chromaticity diagram is used for the two-dimensional graphing of color independent of lightness. X and Y are the chromaticity coordinates calculated from the tri-stimulus value XY is this. In this diagram, the achromatic colors are towards the center and chromaticity increase toward the edges. The color coordinates of the phosphor were obtained as X equals 0.461 and Y equals 0.532. This color point, this color point is pointed on the CIE chromaticity diagram as shown in figure 7, showing that the sample emits a yellowish orange light, and the color temperature is obtained as 3438 Kelvin. In this present work, as I already said in the beginning, this phosphor was synthesized using a conventional solid-state reaction technique. The sample in the present work can be prepared using other methods too. The choice of an eligible host can be done. Other structural and optical properties could be studied using other spectroscopic techniques. Our activity is confined to sample preparation powder form only. Nowadays, the formation of thin films of materials of great importance because of their wide practical applications. Hence, the thin film preparations of the sample may be worldwide. Preparation conditions can be changed and the results can be compared so as to work out optimum conditions of preparations. Here, the spectroscopic properties and photoluminescence of the synthesized sample was studied. Other samples could also be tried. Different factors can be varied to make a good phosphor. There is a wide scope in this present study. So, thank you and have a nice day.